Welcome to this lesson on reactions of alcohols. Please look at the description if you like to skip between the three relevant sections. So the first thing that we should know is that primary alcohols can be oxidized not just once but further again. It can be oxidized to an aldehyde and then it can be oxidized to a carboxylic acid. I don't think I'll be able to fit it in. So let's put this into practice. We have propanol over here and we've put it into this distilling flask over here, and we are reacting it with an oxidizing agent, and this oxidizing agent is dichromate salts, so Cr2O72- with H+. We get this H+ from H2SO4, sulfuric acid, and we get the Cr2O72- from potassium dichromate. Now what happens is that it reacts together to form an aldehyde. So we've got 1, 2, 3, double bond O, and a H. We've got the H here, H, H, H. Now that, if we do not distill it, if we do not cool it down as soon as it's produced, it would continue to be oxidized by the same oxidizing agent to make a carboxylic acid, or in this case propanoic acid, with the double bond and the OH. Now that was the basic detail. Let's go into a little bit more depth. So what actually happens? Well, the oxidizing agent, for it to be oxidized, this needs to have a hydrogen from a C to H, from the C. So for example, we can use this hydrogen to form another bond with the oxygen to make the aldehyde. We always need a C to H bond for it to oxidize. So say for example, we've got H here, so we can oxidize that to an aldehyde, and then we need another H here, so we can oxidize it to make a carboxylic acid. Okay, we just need that C to H bond for us to react with it. We call this a leaving group. Okay, so in the first instance, this actually does leave, and so does this, to make H2O, because it reacts with the oxygen from the oxidizing agent. Same thing here. Even though it might not seem like it, we could say that this H leaves and gets replaced by an OH. We could say that. If you want to know the mechanism in which this actually happens, please look at the A2 video, which is going to come out pretty soon. So, how do we notice this in a laboratory? Well, the orange dichromate will change to green because it has been reduced. Now that's the tricky part. This bit here would be reduced, but this here will be oxidized. Okay, remember, when one thing oxidizes, the other thing must reduce, and that's why we call it a redox equation. So using this distillation apparatus right here, we would only make an aldehyde if we have an excess of propanol and not that much excess or known concentration of the oxidizing agent. The reason why is because if we had an excess of the oxidizing agent, that means it can still react. We will still have enough oxidizing agent available to react with the aldehyde to make the carboxylic acid. So what we do instead, if we just want the aldehyde, we would distill it as soon as aldehyde is formed. But if we want to make the carboxylic acid, we will have no distillation apparatus. Okay, we'll just put it under reflux. Reflux is just basically bubbling over. And when the aldehyde, we have an excess of oxidizing agent. That's important, excess oxidizing reagent. And that will react with the aldehyde to make the carboxylic acid. Okay, so All of this happens in the reflux, but only this and only that happens in the distillation apparatus. Okay, so if you want the color change, it's orange to green. And we can reduce it. We can go back by using sodium borohydrate. And sodium borohydrate, the way that we would symbolize a reducing agent is if we would have a H in square brackets. Now, we don't really need to know that for AS chemistry, but for A2 chemistry, we do need to know that the H is symbolized as a reducing agent. So this is a reducing agent. Now, for a reducing agent, basically what would happen is that the carboxylic acid would go back to the aldehyde, and then it will go back to the primary alcohol. So the next bit is the secondary alcohol, when we have two carbonyl groups attached to the OH group. So what happens is the same process. We would use an oxidizing agent such as CR2O72- with H+, or we can use chromic acid, which has the H2 and CrO4, or we can use permanganate. They're all weak oxidizing agents, and that's important because we will understand why when we talk about the tertiary. So we would react this with the oxidizing agent to make a ketone, and that's a very, very, very big difference between an aldehyde and a ketone. An aldehyde has the double bond at the end. Aldehyde starts with the letter A, so that means it will be at the beginning of the product. Ketone, the O is in the middle, so we can say that the double bond will be somewhere inside the compound. That's one way of remembering it. I mean, it might not be a good way, but that's the way I remember it. So it would end up like this. Carbon has 1, 2, 3, 4 bonds. Make sure you don't write another H here. And if you remember from the other slide, I said that we need to oxidize it. We need to have a hydrogen here connected to the carbon, and that will act as a leaving group and will make the ketone. Again, the color change, orange to green, will confirm oxidation. We do not need a reflux apparatus because we cannot oxidize this any further. The reason why is because we don't have a hydrogen under a leaving group for us to oxidize it any further. Okay? If you notice from this carbon, we've only got another carbon, and that bond is relatively strong, and that carbon over here, which is relatively strong. If you want to reduce it, we would use sodium borohydrate, and that would go back to the secondary alcohol. So, for the oxidation and reduction of the tertiary alcohol, we all know that it is resistant to oxidation. Now, if you looked back at the primary and secondary, don't worry about that, by the way, we would understand that for oxidation to happen, we need a hydrogen connected to a carbon, to this carbon, which is also connected to the OH. That is called a leaving group. These are all other leaving groups though, but we can't use Cr2O72- H+ to split this bond. We cannot do that. We need a more powerful oxidizing agent for us to break it, but then if we break it, technically we're not even ending up with the same molecule as an aldehyde. So we cannot oxidize or reduce tertiary alcohols just due to the fact that we do not have a hydrogen connected to a carbon, which is connected to the OH. And that is it.